What is a musical note? In basic physical terms, sound is a longitudinal wave travelling at a certain speed and frequency. We use the frequency of this wave to determine which note is being played. For example, a middle C vibrates at around 260 Hz. This specific frequency of sound is characteristic to this specific note, which is how we distinguish it. But if you play a middle C on an instrument,
Sorry, okay, go.
and compare it to the sound you get when it's generated by a computer, it sounds completely different. So why is this?
In order to explain these differences in timbre, we first need to look into some nifty 19th century maths called the Fourier series. This maths is used everywhere, from noise-cancelling headphones to file compression to the problem of heat flow through solids. Basically, a Fourier series allows us to show that a sound like this can be broken down into the individual frequencies that it's made of, which are much easier to understand and manipulate. So how does it work?
Fundamentally, a sound wave is an oscillator. Now, an easy way to model this is by using sine and cosine functions, since they're waves and they're relatively easy to compute. Now, say we wanted to build a square wave entirely out of sine functions. Now, this would seem impossible because, well, look at them. However, by using a Fourier series, we can do this by utilizing an infinite sum.
Take sine x, then take sine 3x over 3, a wave with 3 times the frequency but a third of the amplitude. Add the two together and we get this. Then add to this sine 5x over 5. You can see the wave is becoming more square-shaped. From this, you can grasp the overall pattern. As we keep adding successive sine terms, the overall sum gets closer to a perfect square wave. If we could continue this process indefinitely, then we would end up with a perfect replica of the square wave.
From this, you can see how we can add together waves of different frequencies to produce a wave of a totally different shape. Going back to the synthesizer, we can see that a computer is generating a perfect sine wave at a specific frequency of middle C. But if you look at the spectrum of an instrument, you'll see some extra frequencies as well. These extra frequencies are called overtones, and these are what cause the differences in timbre between the computer sound and the instrument.
Overtones fill out a sound by harmonizing, contrasting, and generally interfering with the root frequency. But they don't drown it out, thanks to the mathematical relationship between them, as the Fourier analysis just showed. These complementary waves are why a guitar sounds different to a piano or any other instrument.
So hopefully now you should know why the same note with the same frequency sounds different on different instruments. If you enjoyed this video or found it useful, please leave a like and subscribe. Thanks for watching.